How many galaxies are there out there in the universe? Well, our best estimate as of February 2026 is that there is at least 2 trillion galaxies. Islands of billions of stars just like our own Milky Way galaxy. But how do we actually know that? That's far too big of a number for anyone to have gone out and literally done a count one by one.
1, 2,
11,
3,
92,
4, 5.
12.
Buzz.
So what do we do instead? Well, in this video, we're going to dive into how us astrophysicists get at this number, and then we're going to try and put that number into context. How big is 2 trillion really? So, because we can't count how many galaxies there are in the entire universe, what we do instead is count them in just one specific area of sky, one slice of the universe. One fraction, which we then scale and multiply across the whole sky to get the total number of galaxies in the entire universe. That's the basic idea, but there's a lot of complicating factors to that. First, we need to know the volume of the entire universe, specifically the observable universe. Because light takes time to travel to us, we can only see as far as light has travelled in the time that the universe has been around for. So we first of all have to know the age of the universe, which we thankfully do know from measuring the expansion rate or how fast galaxies appear to be moving away from us. Inverting that expansion rate gives us how long the universe has been expanding for, aka the age of the universe at 13.8 billion years. So in any direction we look, the furthest thing that we're going to be able to see is 13.8 billion light years away. So the observable universe is a sphere with a radius of 13.8 billion light years. That's not necessarily the size of the universe though. I have a separate video on that if you want to check that out. I'll link it in the video description down below. But in terms of how many galaxies are there out there in the observable universe, this sphere at least gives us a volume to work with when we're extrapolating from our little tiny slice of the universe that we've actually done a count in to the full volume. But it only gives us a count for the observable universe that we can actually see. There could be so many more galaxies beyond that. We just don't know because we'll never be able to get any observations in support or against that. The second complicating factor is whether the part of sky you're looking in is representative of the entire universe, because we see clusters of galaxies where there's many galaxies all together in one area, but we also see voids in the universe as well, where there are far fewer galaxies than normal. This all combines to give us a sponge-like structure across the whole universe that's known as the cosmic web. We've seen this in our observations when we take a survey of galaxies and mark their locations, but we also see this appearing in simulations of the universe as well. And yes, while there are local differences in this cosmic web, if you zoom in, you'll see that some areas are denser, but those differences average out over much larger areas of the universe. So much so that the universe is actually both homogeneous, so roughly the same everywhere, and isotropic, roughly the same in all directions. What that means is that it doesn't matter which patch of sky you look at to do your initial count of how many galaxies are in that specific patch, because each little square of sky actually takes a 3D slice through the universe. So even if there is a cluster of galaxies that's maybe fairly nearby in the foreground, in the background, further distances away, there might be a void that will then balance things out. However, having said that, you would not want to pick a patch of sky that's blocked by the stars and gas in our own Milky Way galaxy to do this count. Trying to look through that glow makes spotting and counting galaxies in the background much more difficult, especially fainter galaxies. So while it's true you can pick any patch of sky to do the count, you actually want to pick a fairly boring looking patch of sky to get a more accurate count. Which brings me to my third complicating factor. How do you know you've counted all the galaxies? Well, you don't. Any number we try and put on the number of galaxies in the universe is always going to be a lower limit, i.e. at least 2 trillion galaxies, but probably more. Because Brighter galaxies, either bright because they're nearby or because they're much bigger galaxies further away that have a lot more stars giving out more light, those brighter galaxies are always going to be easier to spot than fainter galaxies. Fainter galaxies could be faint because either they're very far away or because they're smaller with not as many stars. So we use what's known as deep field images to do these kinds of galaxy counts, where you stare at the same patch of sky for a very long time in multiple exposures and add them together to detect as many faint things as you possibly can. What this means is that the number of galaxies that you count depends on what telescope you use to do the count. So a bigger telescope that's more sensitive to light and with a higher resolution will allow you to detect fainter and smaller galaxies. That's why when we use an image from the Hubble Space Telescope to do this calculation, we get a number of around about 200 billion, but when we've more recently used the James Webb Space Telescope to do this calculation, we get that 2 trillion number because JWST can see fainter things at greater distances. Of course, there still will be some galaxies that JWST will miss, and so you can also try to correct your count in an image by watching the number of faint galaxies you count drop off with distance, but that does also require a very big assumption that you'll have the same amount of faint and bright galaxies in the early universe as you do today, like the same kind of spread. And if you start doing little tweaks like that, then they do get exaggerated when you extrapolate from your one slice of the universe to the full volume of the universe. And finally, my fourth complicating factor is what even classifies as a galaxy when you're doing the count. Because believe it or not, us astrophysicists do not have an agreed upon definition of what a galaxy actually is. There's a very fuzzy boundary between star cluster and dwarf galaxy. And there are some objects that have very little stars, but are still very massive due to their dark matter content. So do they count as galaxies? So you can get slight differences in counts from one astronomer to another based on what thresholds they've decided on as what classifies as a galaxy. But there's also the problem of merging galaxies as well. Galaxies get pulled together by gravity, colliding and merging together over billions of years. So if you see something that looks like a merger, does that count as one galaxies or two? Remembering that they might not be merging at all, and it might just be that the two galaxies overlap in two-dimensional space, but not three-dimensional space. This again gets a lot easier the bigger the telescope you have, as you have the resolution to separate when two galaxies are just overlapping, or they're a pair, or when they're merging. So, with all of those caveats and complicating factors in mind, once you've got your count of galaxies in one deep field image from just one patch on the sky, you then work out the area of that patch compared to the area of the entire sky and multiply the galaxy count by that fractional area to get at your minimum number of galaxies in the universe. Now, doing this with just one image gives you a very big error range on the number that you end up with because you could be missing some galaxies. But repeating this with many deep field images gives you a much more accurate estimate. And it's by doing this that astrophysicists have ended up at that number of there being at least 2 trillion galaxies in the observable universe. But how big is 2 trillion really? To put it into context, if you were to try and actually do this full count of the number of galaxies in the universe yourself, one by one, and assuming that you could count one galaxy per second, 2,000 galaxies would take you 2,000 seconds, which is around about 30 minutes. Counting 2 million galaxies would take 2 million seconds, which is just over 3 weeks. Counting 2 billion galaxies would take 62 years, and counting 2 trillion galaxies would take you 62,000 years to do the count. It really is a huge, huge number, and that is only just scratching the surface. There are at least 2 trillion galaxies in the observable universe that we know of. There's likely a lot more than that we just don't have the technology to be able to see yet. Or maybe even more that we'll never be able to see beyond the edge of the observable universe. Now, if you love mind-bending physics like this and you want to get more familiar with working with problems like this, I highly recommend you check out Brilliant, the sponsor of today's video. Brilliant helps you excel at science, maths, coding, whether you're 10 years old or 110 years old. I love Brilliant's step-by-step interactive lessons and personalized practice that gets you to learn by doing, solving problems yourself rather than just passively watching a video. The courses are crafted by world-class teachers from the likes of MIT, Harvard, and Stanford. Whether you want to learn more about how AI works, or brush up on your geometry, or understand the physics behind electric circuits. I particularly love their scientific thinking course, which introduces you to key scientific principles and theories. So from simple machines like gears and pulleys to building rigid structures. I think this scientific thinking course would just really help if you want to gain a deeper knowledge of scientific principles and train up your scientific intuition. So to learn for free on Brilliant for a full 30 days, go to brilliant.org/Dr. Becky, or scan the QR code on screen, or click on the link in the description, and you'll also get 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. So whether you're an adult or a kid, check Brilliant out, and who knows, it could be the start of your path into astrophysics, and maybe in the future lead to a whole new calculation of how many galaxies there are out there in the universe.